In this video, we're going to start looking at completing the square in a little bit more difficult of a context. It's mostly the same. There's just one extra step that we have to go through. So when we're completing the square, it's easiest to complete the square if the number, or if there is not a number in front of x squared. So in these cases, we're going to have a number in front of x squared. Basically, all we're going to do is just divide everything by that number to get x squared all by itself. And then we'll continue on exactly as we did in the last video. So, let's start again by just dividing everything by that number. So we're going to divide this all by 2. Divide this by 2. Well, 0 divided by 2 is 0. And then we get x squared plus 8x minus 7. And so that's a bit nicer. Now we can go through and complete the square on this. So we want to complete the square on this part right here, x squared plus 8x. So let's get rid of the 7, just move it out of our way so that we don't have it getting in the way here. And we're going to add something to the right side in order to complete the square. Now if we add it to the right side, that means we also need to add it to the left side. So to complete the square, we're going to take the middle number, cut it in half, and then square it. So that's 4 squared is 16. So 16 is the number that we need to add to both sides. Alright, then x squared plus 8x plus 16, that will factor to x plus 4 squared. 16 plus 7 is 23. And then we can find the solutions by taking the square root of both sides. So on the left side, plus or minus the square root of 23. And on the right side, x plus 4. Now if we want to solve this for x, we could again split it into 2 separate equations. In this case though, what I'm going to do is I'm just going to take a shortcut here. I'm just going to subtract 4 from both sides, and then we'll get x equals negative 4. Then we'll have the plus or minus square root of 23. So we can write both solutions at once like that. You could write them separately if you want, but I'm going to do this. Alright, once again we have a number in front of x squared, so let's divide everything by 3 in order to get x squared all by itself. So then we get 0 equals, then x squared plus, that'll be 4x minus 6. And again, what we want to complete the square on is this piece right here, so let's get rid of that 6, just move it out of our way. And then we're going to want to add something over here. And again, if we add it to the right side, we've got to add it to the left side. So what we need to add here to complete the square is going to be, we're going to cut this number in half, that's 2, square it, and we get 4. So then we get 10 on the left side. And then this will factor to x plus 2 squared. Then we can take the square root of both sides. That will lead us up here. And we're going to get plus or minus the square root of 10 is equal to x plus 2. And then we can solve this once again by subtracting 2 from both sides. So we get negative 2 plus or minus the square root of 10 equals x. The last thing we're going to do here is convert to vertex form and then also find x-intercepts. Now in the last video we found some x-intercepts, so this one's fairly straightforward in terms of having learned this in the last video. But converting to vertex form, this one's going to be a little bit tricky. So let's think about what needs to happen. So vertex form looks like this. We have y equals a times x minus h squared plus k. That's the general form. So we need to try to take this and turn it into something that looks like that. So to do that, we're going to need to complete the square. So let's do this, start out just like we would if we were completing the square. So let's say add 3 to both sides. And then we get x squared minus 2x, because again, what we're trying to do is complete the square on that part right there. And so we'll get then plus something that we're going to add in a minute. And over on the left side, well, 3 and y, those are not like terms, so I'll just have to leave them like that. but then we're also going to add something else over here from completing the square. So to complete the square, again, we're going to take the middle number, cut it in half. That's -1. Square -1, we get +1. So we're going to add 1 to both sides. Then on the right side, x squared minus 2x plus 1, that will factor to be x minus 1 squared. And on the left side, y, and then 1 plus 3 is 4. So what we can do then is just subtract 4 from both sides, and that will bring us back to vertex form. So y is then all by itself on the left side, because that goes away. And then we have x minus 1 squared minus 4. For finding x-intercepts, again, what we want to do is find where the y value is 0. So if we're looking for where the graph crosses the x-axis, that's the horizontal axis, the y value is 0. So let's plug in 0 for y. And then we can solve this again by completing the square. So let's get rid of this number at the end, because what we want to do is complete the square on x squared minus 6x. So we'll get this -13 out of our way. And then what we want to do is add something to both sides that will complete the square here. So -6, we're going to cut that in half. That's -3. Square it, and we get 9. So then this will factor to x minus 3 squared. 9 and -13 is going to be -4. So then we need to take the square root of both sides. And so we get plus or minus the square root of -4 on the left side equals x minus 3 on the right side. Well, square root of -4, that's 2i. So that's going to be plus or minus 2i equals x minus 3. Well, then we can solve this once again by adding 3 to both sides. So then we get 3 plus or minus 2i is equal to x. So now what we found here is that we have x-intercepts. So right when we plug in 0, we get x-intercepts. And we found that the x-intercepts are complex numbers. That's a bit strange. So what this means actually, and at some point in class I'll actually give you a visual demonstration of what this means. But what this means essentially is that we have a parabola that does not cross the real x-axis. So this x-axis right here, this is the real x-axis. And so this parabola is entirely above, or you could have it entirely below the x-axis. So you can have it where the parabola does not actually hit the real x-axis. So you might be wondering, well, how it is that we can get complex numbers then for the x-intercepts. And that's, again, something I will show you guys in class at some point. It's really something you need to have a visual aid to show. But basically what this means is that the parabola is not actually hitting the real x-axis.